Electrical Theory 101. Definition and properties of positive and negative charges. I'll provide a detailed breakdown of the definition and properties of positive and negative charges. Definition and properties of electric charges. 1. Basic definitions. Electric charge is a fundamental property of matter that determines electrical interaction. Positive charge, plus conventionally associated with protons. Negative charge, conventionally associated with electrons. Measured in coulombs, C, where 1 C equals 6.242 times 10 superscript 1 elementary charges. 2. Fundamental properties. Quantization. Charge exists in discrete units, multiples of elementary charge E equals 1.602 times 10 superscript 1 C. Conservation. Total charge in an isolated system remains constant. Additivity. Net charge is the algebraic sum of all individual charges. Two types only positive and negative charges exist, no magnetic monopoles. 3. Interaction rules. Like charges repel, plus or. Unlike charges attract, plus. Force magnitude depends on charge quantities, distance between charges, medium between charges. 4. Charge distribution. Free charges can move through conductors. Bound charges stay fixed in insulators. Surface charge distribution in conductors. Volume charge distribution in insulators. 5. Charge transfer methods. Conduction, direct contact between materials. Induction, charge separation without contact. Friction, transfer through rubbing, triboelectric effect. Ionization, adding/removing electrons from atoms. 6. Observable effects. Electric fields around charged objects. Potential difference between charged regions. Static electricity phenomena. Electromagnetic force generation. Current flow in circuits. 7. Practical applications. Capacitor operation. Static charge control. Lightning protection. Electrostatic painting. Photocopier function. The amazing world of electric charge. A journey into electrostatics. Good morning, everyone. Today we're going to explore something that's literally all around us, something you experience every day but might not fully understand yet. We're talking about electric charge, and trust me, this is going to be fascinating. Let's start with something you know. Have you ever walked across a carpet and gotten a shock when you touched a doorknob? Or noticed how your hair stands up after rubbing a balloon on it? What you're experiencing isn't magic, it's electric charge in action. And today, I'm going to help you understand exactly what's happening in these moments. The basics. What is electric charge? Think of electric charge as a fundamental property of matter, just like mass. But unlike mass, which only attracts other mass, electric charge comes in two flavors, positive and negative. It's nature's way of playing matchmaker, but with some interesting rules. Like charges repel each other, positive repels positive, negative repels negative. Unlike charges attract, positive attracts negative. Now, where do we find these charges? Right in the atoms that make up everything around us. The protons in the nucleus carry positive charge, while the electrons orbiting around carry negative charge. When we talk about something being charged, we're really talking about an imbalance between these protons and electrons. The quantum nature of charge. Here's something mind-blowing. Electric charge comes in packages. You can't have half a charge or a third of a charge. It's always whole numbers of a fundamental unit we call the elementary charge. That's 1.602 times 10 superscript 1 coulombs if you're curious. It's like trying to buy shoes. You can't buy half a shoe, right? Nature works the same way with electric charge. Conservation of charge. Nature's bookkeeping. Let me let you in on one of nature's strictest rules. Charge can neither be created nor destroyed. It can only be transferred. When you rub a balloon on your hair, you're not creating charge, you're moving it from one place to another. Nature keeps perfect books. The total amount of positive charge minus negative charge always stays the same. Let's make this real. Walking to the Van de Graaff generator in the classroom. See this machine here? It's going to help us visualize what we're talking about. When I turn it on, turns on the generator. Watch what happens to these small pieces of paper nearby. They're being attracted then repelled. This is exactly what we talked about with charge attraction and repulsion. The generator is building up charge and we can see its effects on the world around it. The real-world impact. Now, why should you care about all this? Because electric charge is fundamental to, well, almost everything in modern life. Your phone screen responds to your touch because of charge transfer. Lightning in a thunderstorm is a massive discharge of electric charge. Your nervous system uses electric charges to send signals to your muscles. Every electronic device you own works by controlling the flow of electric charge. Common questions I get. Professor, why does rubber make a better insulator than metal? Great question. It's all about how freely charges can move. In metals, some electrons are free to move around. We call these conduction electrons. But in rubber, the electrons are tightly bound to their atoms. This is why you can touch a 120V wire with a rubber glove and be safe, but you definitely don't want to touch it with a metal rod. Let's break some misconceptions. I often hear students say, electricity flows like water in a pipe. While this analogy helps us understand some aspects, it's not quite right. Electric charge movement is more like a crowd of people in a fully packed hallway. When one person moves forward, everyone has to move almost simultaneously. The effect is nearly instantaneous throughout the conductor. Putting it all together. When we understand electric charge, we begin to understand the foundation of electricity, electronics, and many natural phenomena. It's the key to understanding everything from why clothes stick together in the dryer to how your brain works. Looking ahead. In our next class, we'll explore electric fields, the invisible force fields that surround every charged object. For now, I want you to look around and notice all the ways electric charge affects your daily life. Try this. Tonight, when it's dark, take off a polyester sweater and watch for tiny sparks. That's charge separation in action. Remember, every time you touch something, use your phone, or even think a thought, you're experiencing the effects of electric charge. It's not just a concept in a textbook, it's a fundamental part of our universe, and now you're beginning to understand it. The information provided in this lesson is for educational purposes only. Electrical theory can be complex, and working with electricity is inherently dangerous. Always consult with a qualified electrician and adhere to all local electrical codes before attempting any electrical work. I am not responsible for any injury or damage resulting from the application of this information.